Our final geometry prep topic is going to be two of the most basic geometry formulas that you learn right at the beginning of the year, and you start using in the very first chapter, talking about lines and line segments and points. And you're going to want to know these going in and know where they come from. So the two formulas we're talking about, which I tend not to like to think of them as even formulas. I tend to think of what do these things mean and how can I find them. But these are midpoint and distance. So when you have a line segment, like this one shown in number 1, it goes from the point -2, -1 to 2, 2. So those are called end points. They are the two ends of the line segment. So we have these are end points. And then if we found the point exactly halfway along the length of that segment, which would be like here, we call that a midpoint. Midpoint means right in the middle of a segment, exactly halfway between the two endpoints. So you could think of that as basically, if you think of it like a rise over run thing. Let me get a different color. So from this endpoint to the midpoint, I went up 1.5 and over 2. And then to get from there to the other endpoint, I go up 1.5 and over 2. So these two rise and run are exactly the same to go from the endpoint to the midpoint and the midpoint to the other endpoint. So that's kind of what we're talking about with this term, midpoint. The other thing we want to know is how long that segment is, and you already know how to figure that out. You've just been presented it as something called the Pythagorean theorem instead of, quote-unquote, the distance formula. And I tend to just always think of it as Pythagorean theorem, and the distance formula is kind of secondary and unnecessary if you really understand why distance is what it is. So we're going to find the midpoint of these segments. Now we found this one visually just by basically eyeballing where halfway between those points was. But the way we can calculate it, so using the midpoint formula, is to take the endpoints, which were -2, -1, and 2, 2, and think of these as x1, y1, and x2, y2, exactly like we did in algebra to come up with slope. So we have 2 points, and what we want to know is what is halfway between them. And a way to think of halfway between is what is the average of those two numbers. So if you get an 80 on a test and a 90 on a test, the average of those two grades is an 85. It's the number exactly halfway between the two numbers. And to find that, you would add the two numbers and divide by 2. So if I got 80 and 90, then my average would be 80 plus 90 over 2, which is a 95. And that's exactly what the midpoint formula is based on. It says that the midpoint coordinates are, so the midpoint x value is x1 plus y1 divided by 2, and the midpoint y value is going to be, wow, why did I put y1? Let's just start this whole thing over. It's kind of a mess. Okay. I'm going to also write it out a little clearer. So my midpoint, the x coordinate, is x1 plus x2 divided by 2. So it's the average of the x values. And the y value is y1 plus y2 over 2. So this one, if you see it on like a formula sheet, feels a little weird because it's not saying something equals something. It's not an equation. It's giving you the way to find the x and y coordinates of this ordered pair. So your midpoint has an x coordinate and a y coordinate. And if we look at this one, we would take negative 2 plus 2 over 2. That would be our x-coordinate, because that's x1 plus x2. And then our y-coordinate would be negative 1 plus 2 over 2. So that was y1 plus y2 divided by 2. If I simplify that, negative 2 plus 2 is 0, and 0 divided by 2 is 0. And this one is negative 1 plus 2 is 1, divided by 2 is 1/2. So that means my midpoint coordinates should be 0, 1/2. And if you look at the graph, we found it at that exact point, 0, 1/2. So this complicated looking thing is called the midpoint formula. And rather than memorizing it, I think it's a lot better to think of it as just being halfway between the 2 points. And I go back and forth on whether I think of that as an average, like it's presented here, or thinking about going half of the distance between the 2 points. So looking at my entire line segment, we'll do this on the second one. Looking at the entire line segment, my change in x is 4. I need to go 4 units to the right to get to the other end point. So my midpoint is just half that far. So instead of going 4 to the right, I'm going to go 2 to the right and be on negative 2 for my x value. Then I need to go up 5 to reach my other end point. So on the y direction, I need to go up half of 5, which is 2.5. 1, 2.5. So right here at negative 2, 2.5, that's my midpoint. So the graph also makes it a little easier to just count the lines, but even if I just have the coordinates, so let's say I started here with negative 4, 0, and 0, 5. What I would do is look at this and say from negative 4 to 0 is a distance of 4, and I want to go half that far from where I started. So I think of that as negative 4 plus 2, and then I need to go from 0 to 5. So that's a distance of 5. I want to go half that far, so that's 0 plus 2.5. So my coordinates would be negative 2, 2.5. So there's kind of 2 ways of thinking about midpoint. Either it's the average of the 2 endpoints, like it's the middle of them, or it's half the distance from one to the other. So think of it like starting a journey from one endpoint and going half as far as you need to get to the other side. So hopefully those help you understand midpoint, and the thing that'll be like you'll be expected to know in geometry is this formula. But like I said, I'm not a big fan of formulas, so I don't like memorizing it this way, but you're welcome to do so, and your teacher will probably present it in that way. The other thing we're looking at here is distance. So here they have just coordinates, and you can use that formula or the other method that I mentioned. Either way is fine. Now we want to talk about distance. So distance just means the length of a segment. So you'll see the term length and distance used kind of interchangeably. They mean the same thing. So if I have a line segment and the endpoints are named A and B, the distance from A to B is just called AB. That means how far is it from A to B, and that is also the length of the line segment AB. Line segment, by the way, is written as AB with a flat line over it with no kind of anything on the end. It doesn't have like dots like the actual line segment. And if you have a line that goes on forever, like the ones we've drawn for like functions, then, and this had like point C and point D along it, the notation for that is CD with a double-headed arrow over it. So there's a lot of symbology and notation in geometry that you're going to see, and this is one of the first and most important ones, is differentiating what is a line, a segment, or a distance based on that notation. So if you see a test or a quiz and it says find AB, it means the distance from A to B, or the length of line segment AB. Now, how can we find that distance? We think of any diagonal as just being the hypotenuse of a right triangle. So if I connect this up right here, then I have a leg that's too wide and too high. And we know that from the Pythagorean theorem, a squared plus b squared equals c squared. And c squared is the distance we're looking for. So if I plug in my 2's, I get 2 squared plus 2 squared equals c squared. And then I want just c by itself. So to undo that square, I'm going to square root it, just like when we were solving quadratics. So I get the square root of 4 plus 4, that's 8, equals c. And I know I can simplify this because there's a pair of 2's in there. So my distance is 2 times the square root of 2. So I would say AB equals 2 root 2, and that's how long that segment is. So if you see anything about distance, it's really just the Pythagorean theorem. It's just rebranded a little bit. And if you see it as a formula, it looks really complicated, but it's not. It's just Pythagorean theorem. So I want to look at one where we're just given the points and not a picture, so we can't count it. Because we're going to see that we solve it the exact same way. So if I look at this, my change in x is plus 10, and my change in y is plus 5. So that means that my distance is the square root of 10 squared plus 5 squared. And if I saw this on a coordinate plane like this one, then that would be my run and my rise are 10 and 5. So we can use the exact same method. It's still the Pythagorean theorem, and we would get the square root of 125, which is equal to 5 root 5. So that is how I prefer to think of it, is just the Pythagorean theorem, where A and B, the two legs of the triangle, so I always end up with a triangle, terrible triangle, where A and B are my run and my rise, and this is my distance, the hypotenuse. So this also has a formula, and again, I don't prefer formulas, but I will show you what it looks like, and I want you to understand, again, that it is just the Pythagorean theorem. So run, if you think about the slope formula, so let's go back to slope and say slope is y2 minus y1 over x2 minus x1. That's rise over run. Well, if I'm calling rise and run here the two legs of my triangle, then that means that I have distance is the square root of my rise squared, which is y2 minus y1 squared, plus my run squared, which is x2 minus x1 squared. And it doesn't matter whether you put the x's or the y's first. It actually doesn't even matter which one you subtract from which. Since you're squaring it, you're going to end up with the same number, whether it's positive or negative. So where I put plus 10 and plus 5 here, it's kind of irrelevant. All that matters is the distance is 5 and 10. It doesn't matter whether it's a plus or a minus, because when you square a number, it always becomes positive. So you may see this written with the x's first or the y's. It doesn't matter, but this is the idea is just you're doing rise squared plus run squared equals the hypotenuse squared. And then to deal with that, since we just want the hypotenuse, that's where this square root comes from. So the distance formula is just a fancy rewriting that looks more complicated, but it's still just the Pythagorean theorem. So you should be able to do some practice on this page now with midpoint and distance. Try those two things out. Use the formulas or don't, whatever works best for you. Just to close out, in case you didn't write it, I'm going to write the formulas one more time. So our midpoint formula was the average of the x's, x1 plus x2 over 2. That's the x coordinate. And y1 plus y2 over 2, that's the y coordinate. So you should write this on your paper if you haven't. And then the distance is the square root of, I'll put the x's first, x2 minus x1 squared plus y2 minus y1 squared. And as usual with radicals, if you can simplify like we did here, then you'll simplify that radical as the last step. So try those out, see how they feel. This is a big thing to kind of get a head start on geometry. You're definitely going to want to have this in your tool belt.